All right, geometry, quick overview of 11.2, volumes of prisms and cylinders. So, hey guys, think about what a volume is for a second. Volume is just how much we can fit inside of something. In fact, it's just how many 1 by 1 by 1 cubes you can fit inside of a shape. All right, so to figure out what that value would be, the easiest way to do it is to just figure out how many squares do we have that makes up the base of the shape, right? So that's surface area. That's what we've been doing, right? So what is the surface area of a base, which we'll call capital B? Once we know that, we can just simply multiply that by the height of the figure, right? So the height of a figure. And I'll show you guys what that looks like on the next slide here, because I'm not a great artist with drawing these 3D figures. But essentially for today, all we're doing is we're just taking the area of a base and we're multiplying it by the height. Okay, so that's what gives us our volume. That's how we determine how many 1 by 1 by 1 little cubes we can fit in that shape. Okay, so this is our formula. And it sounds pretty easy, but the B part of the formula changes depending on what the shape of the base is. For instance, example 1 has a regular, right, all the sides are the same, pentagon. Okay, so if we have a regular pentagon, we have to figure out what is the area of a regular pentagon. Well, we know that they give us that each of the sides is 5, right? So we know that. And if you guys remember the formula going back, if you know, like if you kind of break this up into triangles, right? There's 5 triangles. If we know the height of the triangle, which they give us, right, which is super nice of them, it's called the apothem, then we can find this very simply, okay? It's just going to be so the area of a triangle is base times height divided by 2. The base is 5, right? The height of the triangle is 3.4. We divide it by 2. That gives us the area of one triangle. This is a pentagon. There are 5 triangles in the shape, so I have to multiply that by 5. Okay, so we can do it this way. We end up with, well, let's see what that comes out to. 5 times 3.4 times 5 gives us, give me 1 second, 25 times 3.4 gives us 85. 85 divided by 2 gives us 42.5. Okay, so that's our surface area of our base. That's our B, right? B equals 42.5. Surface area of our base. Then I'm going to multiply that by our height. Our height is 8. So if we multiply that by 8, you get 340 millimeters cubed. Don't forget to cube your labels. Okay, I want you guys to pause the video and try this one on your own. Okay, hopefully you did that, but hopefully you see here, guys, that the base, in this case, is a triangle. Okay, this thing's not sitting on its base. So for a prism, every prism has the same base on top and bottom. The only thing that shows that here in this picture is the triangle. Triangle's the same on top and bottom, so this thing's not sitting on its base. So I got to find the area of the triangle, right? So I need my base and my height. I know this is 9, I know this is 15. Got to find this, right? So in order to find that, I can use the Pythagorean theorem. 9 squared plus height squared equals 15 squared. Okay, so if I solve for h here, so we do 15 times 15 for 15 squared, which is 225, minus 81, which is just 9 squared. Okay, if you subtract those, you get 144, which is a nice number because the square root of 144 gives us 12. Okay, so this is 12. So the area of my base is just going to be the base times height of the triangle, 9 times 12, divided by 2. I can simplify this a little bit here. 9 times 6 gives me 54. Okay, so I know it's 54 times my height. Height could be challenging to figure out. It's just the distance between the bases. Okay, so in this case it's 10. So if I multiply this by 10, I get 540 feet cubed. All right, so that's example 1B. Moving on, guys, we're going to look at cylinders as well. Now, cylinders, there's nothing different. And I don't know why they even made this a different deal. It's still base times height, but now the base is given by the area of a circle, right? Because the base is a circle, which is pi r squared. So for the area of a circle, we have pi r squared. That becomes the b value, right? So the area of the base of these things is just pi r squared times the height. So for this one, we have the radius is 3, so pi times 3 squared times 8, which is the height. This is the same thing as 9 times 8, which is 72 times pi. So I think in their books they're going to want you, in your books they're going to want you to round this to the nearest tenth. So 72 times pi. Let me do it really quick on my calculator, and I get 226.2 centimeters cubed. Okay, for 2b, this is a little bit different of a challenge here. Notice they don't give me the height. Okay, they don't give me this distance. Let me do this in red here. They don't give me this distance right here, which is the height of the cylinder. I have to find that, right? And also, they didn't give me the radius, but that's easy to find, right? Because the diameter is 10, so the radius has to equal 5. So let's figure out the area of the base, which is pi times r squared, which is 5 squared, which equals 25 pi, right? 25 pi, we'll just leave it in these terms for now, but now I got to find this height of the cylinder. So notice that just gives me a right triangle on its side, right? So hopefully you're connecting that. This is 10, the hypotenuse is 16, so I can figure out the height, right? So 10 squared plus h squared equals 16 squared. H squared is equal to 256, I believe, minus 100, okay? So h is equal to the square root of 156. Okay, so if I take the square root of 156, that gives me approximately 12.4. Well, let's just go to 12.5. 12.5. Okay, so I'm going to take 25 pi multiplied by 12.5. Okay, so 25 times pi times 12.5. And that gives me 981.75 centimeters cubed. All right, so that's example 2. We're going to keep cruising through here. Let's see. What's the next one? Cavaliere's principle. Hey, this just says that if something is oblique, the same rule applies. So it says if two solids have the same height and the same cross-sectional area be at every level, right, then they have the same volume. So if this thing just shifts, if it shifts so that it's a more oblique and not like at a right angle here, it still has the exact same area as if it didn't shift. So example 3 kind of shows that, right? So for example 3, you're going to just figure this out the exact same way. So this would be pi r squared times the height, right? So pi times 36 times 12, which just seems to be like a pretty big number. 36 times 12 equals 432 times pi. So this is equal to 1,357.2 meters cubed. Okay. To compare volumes, it says find the volume of both shapes. Sometimes they want to know the difference, so you would subtract them, but sometimes they want to know how many times bigger something is. So then you just divide them, and I'll show you how that works. So let's figure out what these are. We know that the radius of this first cylinder here would be 7.25. And by the way, it's always a good idea to read the question. I'm just attacking the problem right away. But it says about how many times as much popcorn does the larger container hold. So I'm just going to compare the volumes. Okay, so my radius on the larger container would be 11.4, right? So I'm just going to plug this into my formulas for this. So this would be pi times r, which is 7.25 squared, pi r squared, times the height. And then this one would be pi times 11.4 squared times the height. And let's just see what these numbers come out to. So 7.25 times 7.25, that's 7.25 squared, times 18 times pi gives me, this one gives me 2,972.34 approximately centimeters cubed. And the other one would be 11.4 squared times 18 times pi, which is 7,349.06. I encourage you to check me on these numbers. There's always a chance that I make a mistake. But it says how many times bigger, right? So I just want to compare, like, so basically we're saying 2,972.34 times what number, or how many times bigger, right? How many times bigger? So times what number would give me 7,349.06. Okay, so I could divide both sides by that, 2972.34. Okay, and when I do that, I get 2972.34. I end up with approximately 2.5-ish, it's like 2.47-ish. So my best answer there is G. All right, guys, that's it. The homework, I'll have a homework sheet for you up on Classroom, so don't worry about this too much. But you're just finding the volume of prisms and cylinders today. All right, guys, take care.